Welcome to Chem Camp. I'm Mrs. Newman. Are you looking for a video to help you convert between grams and moles of a substance, or moles and grams of a substance using its molar mass? Well, then this video is for you. Let's learn a little chemistry. First and foremost, molar mass is the number of grams of a particular substance in just 1 mole of that substance. So this gives us a ratio between grams and moles of a particular substance. Let's see how this is applied to these types of problems. Number 1 states, calculate the mass of 3.5 moles of water. So what I always highly encourage students to do is to start one of these problems by pulling out what I call the given, which is going to be a number and unit that they give you to start with. So here, the 3.5 moles of water, that's going to be our given. And I'm going to take that and I'm going to write it to the left side of the paper, 3.5 mole of H2O. The very next thing you need to pull out is what exactly it is you want to solve for or you want to get to. This is going to be just a unit. However, they're rather tricky here because they don't give you another unit. They ask you to calculate mass and expect you to recognize the fact that mass is measured in grams. So the unit we want to find here is actually grams, and we're going to call that the want. I'm going to take my want, or grams of H2O, and write that to the right side of my paper. This way I know what unit I'm starting at and what unit I'm trying to get to. Because what we can do is apply something called dimensional analysis, which I highly recommend. Otherwise, students are always trying to guess, well, do I multiply here, do I divide here, or they're trying to memorize and eventually they forget. However, if you use dimensional analysis and let your units guide you, you're always going to have a skill set to fall back on. So let's try it out. Here, we're going to set up a ratio. So we're going to put a multiplication sign and then a division sign. Now, we have moles of H2O that we want to actually get rid of. So anytime you want to get rid of a unit, you bring that to the bottom of your ratio. So we're going to put mole of H2O to the bottom there to cancel. Now, since we have this concept of molar mass that relates moles of a substance to grams of that same substance, we can go from moles of H2O on the bottom to grams of H2O up top. So now that I've canceled the unit I wanted to get rid of, and I've got the unit that I wanted to get to at the very top of my ratio, I know I've set up the ratio correctly. The only thing I need to do next is calculate molar mass. So we're going to calculate the molar mass of H2O, where we've got 2 atoms of hydrogen times 1.01, the atomic mass of hydrogen from the periodic table, and we've got 1 atom of oxygen times 16.00, the atomic mass of oxygen. We're going to take the sum of those products and get a total of 18.02 grams per mole. Now, since I've got my units set up in my ratio, then I know exactly where to plug in numbers. Because the 18.02 is with the grams in the molar mass, that means I'm going to put the 18.02 with the gram unit in my ratio. And since molar mass is always for 1 mole, I'm going to put 1 with the mole. So here I'm going to take 3.5 times 18.02, and my calculator tells me I've got 63.07. However, in that given 3.5, I've only got 2 sig figs. So I can only have 2 sig figs in my answer. So I'm going to report my final answer as 63 grams of H2O. Let's try a second one. Here in the second problem, they ask how many moles of MgOH2 are in 22.0 grams in a 22.0 gram sample. So once again, our given is a number and a unit. That's going to be the 22.0 grams. And we're going to take that and write it to the left side of the paper. 22.0 grams MgOH2. And this time they ask us to get to moles of MgOH2, which is our want. So we're going to take moles and write that to the right side of our paper. Once again, set up our ratio. And this time we have grams of MgOH2 that we want to get rid of. So we're going to take that and write it to the bottom of our ratio. And again, since molar mass compares grams of a substance to moles of a substance, we can put mole of MgOH2 at the top of that ratio. Since I've canceled the unit that I was starting with and wanted to get rid of, and now I've got the unit I was looking for at the top, I know I've set that ratio up correctly, and now I just have to calculate the molar mass of MgOH2. So I've got one magnesium atom, so it's going to be 1 times 24.30. And now I've got a polyatomic ion with parentheses, so that subscript 2 gets distributed to each of the atoms inside the parentheses. So I've got 2 oxygen atoms times 16.00, and I've got 2 hydrogen atoms times 1.01. I'm going to sum those products. So I've got 24.3 plus 32 plus 2.02, which gives me a grand total of 58.32 grams per mole. Once again, that 58.32 is with the grams in the molar mass, so I'm going to put the 58.32 with the grams in my ratio. This time it's on the bottom. And of course, molar mass is always for 1 mole, so I'm going to put 1 on top. So what this means is I'm going to take the 22 and multiply it by 1, which gives me 22, which means I'm going to do 22 divided by 58.3 in my calculator, and that gives me 0.3772. However, in my given, I've got just 3 sig figs, so I'm going to round that to 0.377 moles of MgOH2. I hope this helps you with your mole conversions. For more chemistry content, continue to follow along. See you soon.